So we looked at very, very briefly last unit what a quadratic equation looks like when you graph it, but this is where you get this shape from. So the bridge is going to happen there, St. Louis Arch, McDonald's is 2 of them.
My camera will be my eyes.
Or you could just watch the video later.
Yeah, but I don't
Here's what we're going to be looking at today, just some vocabulary, get used to talking about this kind of graph, and then we're going to graph them. We're going to go back to completing the square. We're going to convert to standard form, and then the big thing at the end is called maximum problems. This is our first unit that's going to have a lot of graphing. So is Unit 5 and Unit 7 and Unit 8. We're going to graph our butts off this semester. So if you don't like the little graphs in your workbook because they tend to be a little smaller than I would like, or you don't like drawing graphs, look what I have for you. Now, let me tell you the beauty of these. Number one, they're double sticky. So they have sticky on the left and sticky on the right. And so you can just put that right into your notebook and it will stick there forever. $1 if you'd like to buy a pad, no tax. Nice. So anyway, well, it's $1, so buy a new one if you want it. Again, you don't need to have it. It's just some people don't like drawing out the axes every time we do a question, so completely up to you. So let's look at it. If you toss a ball to your friend, the path of the ball would look like this. This is why I don't teach art. What's that? Oh, apparently I'm not as bad as I thought. Who's that? I am not bald and naked. Hello? Yeah, that's my friend. We won't talk about it. I am not bald or naked. Not at all. I may have no shirt on, but that's beside the point. A skirt, perhaps. Alex, catch and take your earphone out after you've caught. Throw it to somebody else. Gentle, gentle, gentle. It's like I'm talking to my dogs. Gentle. That was actually not bad without glasses. Toss it.
I don't think my sight has anything to do with it. It's just depth perception and whatnot.
Toss it to somebody else. Just toss it.
Hey, Aaron.
Usually you make sure the person's looking first. Toss it to somebody else.
Sorry.
Okay, and the last one, toss it off to somebody. What does the path of the ball look like? Why? Yeah, so we know that the force of me throwing it, whoever throwing pulls it up, it's going to reach a certain height, and then gravity's going to pull it back down. That's why this particular shape is so common, because we love gravity. So a ball's going to go up, hit some kind of maximum height, and come back down. Hopefully we catch it.
I'm not good at catching things sometimes, but yeah.
This shape is called a quadratic function. Not in the math world. General form looks like y equals ax squared plus bx plus c. Where have we seen that before?
Last unit.
Yeah, last unit and all the factoring that you did all the way since grade 9 all had to do with quadratic equations. You can tell if an equation is quadratic if the highest exponent is 2, another name for a quadratic function is a parabola.
What?
Parabola. That's not parabola. People will think you're weird. That's parabola.
You said you could run either way. I probably would have said it's
Yeah, it's parabola.
I was going to ask you to stop, but then I was like, that's weird.
It's parabola. So formally, they're called quadratic functions or quadratic equations. This is like their little pet name. So this is like Abigail versus Abby, right? We call them parabolas just because we like them that much. Arch is really an architect term. It's not really a math term. but I mean, it's something you're familiar with as well. Here's some fun facts about quadratic functions. A parabola can have one of two directions. So if we think about the ball that we just threw, or we talked about the cannonball coming out of the cannon, it can go what we call down. Mathematicians, not creative people, that is down. What's the other possibility? Up. Okay, that's a big fat lie. There are two other directions, but you'll never meet them unless you go to university and study math, but they can go left and right. But for your world, they only go up and down. A parabola can have only one y-intercept. Only one. So just like a line can only have one, it can never cross two. Same with the parabola. So for example, if my parabola points down, it's only going to cross once. If my parabola points up, no matter where I put it, it's still only going to cross once. Okay, there's nowhere else it goes to the side, which that doesn't exist in your world. It can only have one y-intercept. What about x-intercepts? Well, this is what we did last unit. So how many different solutions can a quadratic equation have? 2 or 1 or none. Remember, that's what the discriminant tells us, is how many roots, how many solutions, how many intercepts. So it can have 0, 1, or 2. Unlike a line that can only have one.
0, 1, or 2 x-intercepts.
So here's an up parabola that has no x-intercepts.
Does it have to have a y?
It will always have one y. Here's a down parabola that has no y or no x-intercepts. Here's an up parabola that has 1. So what it does is we call it sits on the x-axis. So it just touches that point but doesn't cross through. Here's a down parabola that has 1 y-intercept. I mean x-intercept. Here's an up parabola that has 2 x-intercepts. And here's a down parabola that has 2 x-intercepts. Next year in grade 12 math, you'll learn equations that have 3 x-intercepts, 4, 5, 6, 7, 8. Infinite. What we're going to talk about now is just the vocabulary you need to know, and that's all the practice will be today, is what do all these words mean. We'll get into the actual math behind them a little later on in the unit. Vertex is going to come up over and over and over and over and over. We'll use the vertex 1,000 times this unit. Kate?
It's the highest point.
What if the parabola goes up?
It's the point where it doesn't go all the way in the parabola.
I like that. I'm not sure I love that definition, but I like the concept. There is no end because these go on forever because they've got arrows on the end. The highest point on the arc. What if it's an up parabola? Who just said that? Say it again. Say it again, Ava. It's called the turning point of the graph.
Ah, good one.
It's called the turning point of the graph. Grabbing your red pen, I'm going to show you after the definition how we express the answer. This would be given as a coordinate point with an x value and then a y value. So it's an actual point on the graph is called the vertex. grade 6 maybe. And there's still grade 9s that can't do them.
Some might have done
I kid you not, I can't remember if I was telling you this last week. We were playing this mental math game in my grade 9 class, and the question was 12 times 10. And the kid went, 12?
Are you kidding? It's just like
No, 12 times 10 is not 12. No.
it's just like
No,
12, it's basically just 12
not.
with 0 on the end.
So, list of words like this is very left brain. I'm going to do it right brained on the diagram. Right about here would be the vertex. Okay, it's where the graph goes down, 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 down on the left. Suddenly it stops and starts going back up. That's called the turning point. The next word I'm going to do on the graph first, and then I'll give you the definition. Axis of symmetry is a vertical line that cuts the parabola into 2 equal halves. So what does it mean if something is symmetric? Yeah, mirrors it. Yeah.
It means that like no matter how much you rotate it, or I guess it's more so okay, no matter how much you rotate it, it'll look the exact same.
Is the human body symmetric?
Somewhat.
So some say yes, some say no. So let's talk about who says yes. Okay. Somewhat, so a little in between. So we have a right hand, a left hand, obviously. We have a right eye, a left eye. We have a right foot, a left foot. So there's an idea of symmetry there, but are your two sides exactly the same size? No. Typically, everybody has one foot that's a little bit larger. What about your internal organs? Your heart's on the left side, right? Your gallbladder's on the right side. So some people say, well, to little kids it's symmetric, but you guys know it's not really symmetric. So that's called the axis of symmetry. And parabolas are symmetric. That's going to help us later when we graph it, because once you have half of it, you can just reflect it to get the other half. What kind of line is this axis? And please don't say straight. What kind of line? Yeah, not what I'm looking for, though. Think again from last semester, everything you learned about lines. You can't have one parallel line. What kind of line is it? Vertical. Who just said it? High five back there. It's vertical. And so I just want you to put back in your head, what do you know about the equations of vertical lines? This is going to become important in a second. What do you remember? There's no y-intercept, yes. And what do you remember about the equation of any vertical line? So y equals mx plus b doesn't work because there's no b, there's no slope. Kind of. It's something different. You should have looked at specifically vertical and horizontal. It's an undefined thing, but what's the equation of any vertical line? It's x equals a number. That's going to become important in a second. So there's no y in the equation because there's no slope in the equation. For the wordy people, the definition of the axis of symmetry, the imaginary line. Ethan can put straight if he wants to. The imaginary line, the imaginary line that cuts the parabola into 2 equal parts. Imaginary line that cuts the parabola into 2 equal parts. It's always going to be vertical until later when you have those sideways one, and then it's horizontal, but we're not talking about those. And the way we express it is always x equals a particular number, and I'll show you later how to find out what that number is. But that just becomes, because it's a vertical line, that's the equation of a vertical line. The maximum or minimum, you're going to have one or the other. What kind of parabolas would have a maximum value? Down parabolas, right, because they go like this. They've got a high point, which is the maximum. What kind of parabolas have a minimum? Up parabolas. Definition is either the highest or lowest point.
Okay. Yeah, maybe you should have saved your definition for later.
Exactly.
Wait, I think that sounded a little more.
Kind of. You'll see in a second it's how we state the answer that's different.
I think that sounded a little more jerky than it did in my head. I was trying to be encouraging.
Go, Alex. Yay.
I apologize, Alex.
We need to just like talk a little more in our head, not so much outside of our head today. So the way we state the answers has two parts. The first part, we either state if it's a max or a min. Okay, so it's one of those two words, not both, just depending on the direction. And then it's y equals a number. So isn't it the same as the vertex? Yes and no. It's the same y coordinate, but it's just the max or min and the y value. We don't talk about the sideways ones. We don't talk about them. I'm not even supposed to tell you they're sideways ones.
It's not fair. Well, learning is learning.
There's like so much math I'm not even allowed to tell you about. You have no idea.
So we let figure that on our own.
Perhaps.
Why aren't you allowed to tell?
Well, because it would take like 5 years to tell you everything, but. The direction. Okay, up, down are the choices. What's a definition? Ooh, except I don't like the word arc because that's not a mathematician word, so something like that. Did you just say parabola? Okay, so the way, not Ebola, no, that's something different. The way the parabola is formed, I'd like a different word. Pointed, I like that.
And that's direction. Following along is tricky.
There are only two choices, again, until later. If in your world there's only two choices, what are the two choices? Now keep in mind, mathematicians are generally lazy people. We also don't like words. If we can avoid using words, we do that. So we don't actually even write up or down, we draw little pictures. This is how we would state that the direction is up. This is how we would state the direction is down. We just draw little pictures. Why do we hate words so much?
Because mathematicians are lazy, as you said.
Because do we all speak English? Right? That's why we don't like words.
If I was on a test and I wrote down up, would I get it wrong?
I would put like an angry face. Grrr.
Well, to me, remember, up is the U.
Oh, up is a U. There you go. Up is a U. That's very right-brained. I like that.
Down is the N.
Oh, an N and down. There you go.
And
Domain and range are nothing new. You did them with lines. Domain and range are going to come back for the rest of your lives forever and ever, ever. They're going nowhere. What is the domain of any kind of graph, whether it's a line, a parabola, something funky you haven't seen yet? All the possible x values. It was like so long ago.
so range is really different.
Range, all possible.
Y values.
How I remember which is which is I'm very right or left-brained, and so I say, well, which comes first alphabetically, domain or range? Domain. We like to put things in order, left brains. So domain comes before range alphabetically. What comes first, x or y alphabetically? X. So domain goes with x, range goes with y because they're both alphabetical. I'm going to wait to show you how we write it because it really depends on the question. There isn't really one way I can just show you, so we'll talk about that in a second. X-intercept and y-intercept have not changed, whether it's a line, whether it's parabola, whether it's something else. Give me the definition of the y-intercept. Where the
Y-axis.
where the graph, we'll say in general, graph, function, equation, crosses
Crosses the Y-axis.
the y-axis. X-intercept.
Where the graph crosses the X-axis.
Oh, we forgot to put these on the graph. Oh, well, I'll get there in a second. Y-intercept is always going to be a 0 and then a number in a coordinate pair. Why is it always 0 and a number? Because the x value at the y-axis is 0.
What was the last thing you drew on the thing, like with the
That's all. It's max min.
Oh, like just that general.
Yeah, I forgot to do a couple in there, so I'll go back. Give me the general form of an x-intercept. Number then 0, because we know the y value is 0. So in terms of the words that are new, vertex is new, axis of symmetry is new, max min is new, is direction is new. The rest are just general terms for any kind of graph. So going to our graph, these arrows here are what's going to tell you the direction. If they're pointing up, it's up, down, it's down. The domain is where we look at the x-axis and we look to the left and to the right. The range we look at, the y-axis, so we look down and then we look up. Y-intercept is where it crosses the y-axis. How many y-intercepts can a parabola have?
1.
Always one?
Sometimes.
Nope, nope, always one. Always one.
It can have.
X-intercept is where it crosses the x-axis. X-int. How many x-intercepts can it have? 0 or 1 or 2. That's it, no more than that. So all we're going to do today is look at a graph of a parabola and state all this information. What's the vertex? What's the axis of symmetry? What's the max min? What's the direction? What's the domain? What's the range? What's the y-intercept? What's the x-intercept?
I hadn't thought of that.
How do we label these?
For which one, sorry?
Because like the marker of where it is, like the 0. I was thinking we write coordinates.
Yeah, well, remember, that's why we did this here, right? Okay, so vertex definition is the turning point. It's also technically the highest or lowest point. So in this case, it's going to be right here. It's always a coordinate pair, so brackets and an x value and a y value. So what's the x coordinate of the vertex?
0.
And what's the y value of the vertex?
-5.
-5. So that's how we state a vertex. It's a coordinate pair, 0, -5. Axis of symmetry is the imaginary line cutting right through the graph. And what's lovely about the vertex is it also gives you the axis of symmetry. It's just you need to remember is how do we present the answer. Answer is always x equals a number, and the number comes right from the vertex. So if the x value is 0 in the vertex, the x value in the axis of symmetry is 0. So I'm just going to put an arrow. It comes right from that guy over there.
I'm going to draw that so I know what that is.
The max min, we give 2 pieces to the answer. The first we state whether it's a max or a min, and then we state the value. Is this a max or a min? Does it have a high value or a low value? It has a min. And then the second part of the answer is y equals a number. Where do you think that number comes from? It's the vertex. So once you have the vertex, you actually also have the axis of symmetry and the max min. So in this case, it would be y equals -5.
Film favors with fun. Basketball. Yay, references to early to things that happened before.
The direction, we have 1 of 2 choices. It's either up or down. We don't write the words. We just draw a little picture. Does this parabola point up or point down?
Up.
Point up. The domain. There's 2 different ways to write domain, and I don't know which one you did last semester. Can somebody remind me how you did domain last semester? So if you had a line, what was the domain? Did you do XER? Or did you do negative infinity to infinity?
You just wrote an X.
You can't just write it's either XER or negative infinity to infinity. Okay. Okay. So I'm going to put the arrows on here to show you the direction. And for the domain, what you're going to do is look to the left and look to the right. And you want to know what's the very lowest point on the x-axis, what's the very highest point. So because of the arrow, what does it mean this graph is doing? Going on forever and ever and ever and ever and ever. So for example, if we come here to -5, am I going to hit graph if I go to -5? What if I move down to -10? Now I'm not going to hit it on this paper, but am I going to hit graph if I could keep drawing this graph? What about -20? What about -50? What about negative 100? So what's the lowest value for the domain? Negative infinity. It's going to go on and on the left-hand side. We're going to do the same on the right-hand side. If I come to 5, am I going to hit graph? Yes. If I came to 10, not on this paper because I don't have enough room, but if I could keep drawing at 10, am I going to hit graph? What about a 20? What about a 50? What about 100? What about 27,000? So what's the very largest value of the x's? And then so we take all the numbers from infinity to infinity, and what are all the numbers in the world that go from every single value, negative and positive, and fractions, and decimals, and radicals, and irrational numbers, what are all those numbers put together?
Real numbers.
They're real numbers. And so what I need to state mathematically is x can be any single number in the world. And so mathematically, we start with the x. Rewrite this curvy E, which is not an English E, so it doesn't have straight lines. It's like a C with a line through the middle. That's a Greek letter. Anyone know what Greek letter it is? Epsilon, it's called. And then we put a capital R that has a double bar in the front.
What if we mix the, like, what if we don't, like, what if we just write XCR?
That is how you write XER.
What if we write just like X?
So what if I spelt your name in Greek letters? Are you going to be upset? Yeah, because that's not the way your name is spelled. This is very specific math notation. Okay, so it has to be that X, that curvy E, a double bar R. What that is saying, without using all the English words, it's saying X can be any single number in the world. I want you to highlight that and circle it and put a star beside it and then some glitter and some flashing lights.
I love that.
It is the bonus point I call, because every single parabola you are ever going to meet is going to have that domain. Because it's always going to have arrows pointing up if the direction is up. And what if I flip it? What if I move this parabola down? It's still going to have arrows pointing to the left and right. So for any question that it says, what's the domain of a parabola, you don't even need to look at the graph. You don't need to look at the equation. It's always going to be XER.
Okay.
Until they go sideways, and then that's not true.
Is it the same for the range?
No.
Why?
No. No. Now, when you did lines, it was always XER and it was always YER. With parabolas, you need to look at the range. Is there a low point to this? Yes, there's a clear stopping point. So if we look down at the bottom of the x-axis, or bottom of the y-axis, right, where do we run out a graph? So do I have graph at -1? Yes. Do I have graph at -2?
Yeah.
Do I have graph at -3?
Yeah.
-4?
Yeah.
-5? -6? There is no graph at -6. It doesn't matter where I draw that line, I'm not going to hit a graph. So unlike a line that goes forever in both directions, if we look at the range, the parabola is going to have a clear stopping point. So grab your red pen.
Wait, by graph do you actually mean a line as opposed to the plane itself?
I'm not looking at the axes, I'm looking at the function.
Oh, okay, that makes sense.
If your parabola goes up, your range is always going to look like this. It's going to be whatever the min value is. Sorry, that's the other way. Sorry, I lied. Because that doesn't match XER. My fault. It's going to be y is greater than or equal to the min. What if the parabola goes down? It's going to be y is less than or equal to the max. Yep, whatever that value is, we're going to stick it in there.
Y is equal to or
Greater than or equal to the min. If it's an up parabola, y is less than or equal to the max. Well, let's just look at y. Well, the very bottom number here is -5. Well, what about the top? So let's say, for example, am I going to have graph at 5? I guess that's 4. Am I going to have graph at 4? What about at 8? What about at 10? What about at 12? Okay, now I'm running out of graph on my paper, but if I went further, am I going to hit the parabola? Well, it keeps on going forever and ever upwards, so when am I going to run out of parabola? Never. So what's the highest value? Infinity. So how do I mathematically say all the numbers from -5 and to infinity? Well, that's how I say it mathematically. Y is greater than or equal to the min. What if the parabola flipped down? Well, here I'm going to hit a high point, and my lowest point is going to be -infinity. So how do I say all the numbers between -infinity to a number? That's how we say it. So because this is an up parabola, my range is going to be y is greater than or equal to, which is -5. Okay. The intercepts, you just pick them right off the graph, just like you did for a line. So what is the y-intercept? So where does it cross the y-axis? Happens to be the same as the vertex, won't always be. And the x-intercepts? -3 and 0, and the other point 3 and 0. Confirm?
Wait, intercepts, do we put the coordinates or just the
Coordinates.
whatever the x-axis?
Coordinates, remember on this page we put how we write them?
Oh, yeah, that's fuzzy, remember?
Okay, let's do another one.
Okay, so just basically whatever the coordinates are.
Vertex. Vertex you pick right off the graph. You're looking for the x-coordinate and the y-coordinate. Where is the highest point of this graph? I heard 3, 3. 2, 3. 2, 3 sounds confirmed. The axis of symmetry always starts with x equals. The number comes right from the x value of the vertex. So this axis of symmetry is x equals 2. I always do the direction next because the direction actually tells you the max min, so I always jump down to direction. Is it pointing up or pointing down? Pointing down. Because it's pointing down, do we have a max or a min? We have a max. And the max is always y equals, and where does the value come from? Right from the vertex, so this is y equal to 3. The domain is the freebie point, it's the gimme point, because it's always going to be the same till lunar. What's the domain? XER. The range you can think of logically, or you can just memorize the two sentences above, completely up to you. It comes from the direction. And so this one is going to be y is less than or equal to 3, because it comes from the max, which comes from the vertex.
So, and then max 3, sorry. For whatever reason, it's hard to keep up. Maybe that basketball scrambled my brain a bit. I don't know.
Y-intercepts you pick right off the graph, so just take a look at the y-axis. Where does it cut through? 0, 0. Remember, it's a coordinate point, 0, 0. The y or the x-intercepts also come right from the graph, so where do they cut through the x-axis? So 0, 0 again, and the second one is at 4, 0. How are we doing so far with the vocabulary? Now, someone mentioned a couple weeks ago that you hadn't done much graphing last semester. So I put the instructions how to graph. If you've never seen this before, they're there. If you have, no big deal. So what we're going to do for the next example is we're going to graph it on our calculator, sketch it, and then do the exact same thing. So if you're not given the graph, that's why you have this lovely graphing calculator. Did you graph last year or no, or last semester or no?
Yeah,
A little bit? Okay, so I'll go through it fairly quickly. If you need extra help, come and see me. It's the buttons that are on just below the screen that are all your graphing buttons. Some of them you'll never use, but there's some we use a lot. So to graph, you go into your y equals. And I always say if you have crap in there, just clear it out. So you just hit clear to physically clear any crap that you have in there left from something else. We type in the equation. We're doing example 3. So it's negative 2x squared minus 6x plus 20. So negative 2x squared minus 6x plus 20. Then we have to set the axes. Just like if you were going to draw this graph, you have to decide the scale of your axes. Well, you have to tell the calculator the same information. It's got some built-in functions that actually helped you out. So I'm going to go into the zoom button, which is that middle graphing button. And what we're always going to pick until Unit 7 is Zoom Standard. What Zoom Standard does is say to the calculator, I want you to go from negative 10 to 10 in both directions. So Standard is negative 10 to 10. Okay, so just pause there if it said invalid. Okay, if you follow the directions to me, do you have the same graph? Okay, let me go back and talk to the invalid people, and I'm going to purposely make a mistake the way I'm punching in this calculator. And so when I go Zoom Standard, it's going to come back and say error. The calculator's pretty smart, and this is usually whenever you get an error. If you pick go to, the calculator will tell you what it thinks the error is. So I'm going to pick go to. And the calculator flashes on what the error is. What did I do incorrectly for this one? So I used the subtraction key instead of the negative key. So you change that, go back to your Zoom 6, and it should work. Sorry, to do what? So you just, okay, so if you go to go to, it will flash on what you think it thinks it is, so you just need to put the correct thing in. It's usually a negative in subtraction with these, but not always. Did anyone else get a different error, like it's flashing on something different? Okay, what does yours look like?
It's like right beside it, like that.
Okay, I want you to go back into Zoom. We'll make sure you have the exact same equation. So negative 2x squared minus 6x plus 20. Okay, and I want you to zoom again and pick Zoom 6. Okay, come show me. Okay, come show me. Okay, so do you see at the top here how you've got that stat plot black? The problem is you're trying to do a stat plot and a regular graph. And calc is like, what's going on? So you want to always make sure those numbers up there are white, what we call white. So I'm just going to go on top of where it says stat plot and just turn it off. And do you see now there's nothing? Now try it again, it'll graph.
Mine was like this.
That is so weird. Because if you look in the 6, you have done a negative 6, not a subtract 6. So it's actually multiplied those together.
Okay.
So we will just fix that. So I'm just on top of the negative. I'm going to hit subtract instead.
Okay.
And see, to the calculator, that wasn't an error.
To the face, accidental,
There you
Oh,
go.
okay.
Okay.
equals this. And this.
You didn't zoom 6.
Oh, okay.
Everybody else? If your axes are not on, let me know, because that's fixable. Okay, so you should have exactly the same graph, the axes, everything. Now the problem with this one is, can we see the vertex? No. So sometimes Zoom Standard doesn't do what we need it to do, so we need to go in manually and tell the calculator, hey, show me the rest of this graph. So where is the vertex going to be? Well, it's going to be up higher here somewhere where we can't see it. So we need to see more of the y-axis. So I want you to hit your window button, which was in between y equals and Zoom. And this is how to manually set your window. And what that's doing, it's telling the calculator how many units you want it to show. Zoom Standard set it to do negative 10 and 10. That's why it looks like that. We need to go and change the y max because we want to see higher on the y-axis. So I'm just going to bump down to y max. Give me a value that you think is going to show us the top of the parabola. 20 was the first number I heard. Okay, then I'm going to hit graph to go back to the graph, and let's see if we can have a clear picture. Nope, still can't see the top, so back into window, back down into y max. Okay, 100. Okay, hit graph. Can we see the top of the parabola? Now, generally you want your graph to pretty much take up your window because it means you're going to be able to see the values better. Does this take up our window? So it probably tells us what about 100? It was probably a little bit too big. So let's go back and just bump it down. So 20 was too small. 100 made it really low on the screen. 40. Is that a better picture of the parabola? Okay, does it take up the full screen? Not quite, so we can probably get a better picture. So 20 was too high, 40 is still a little bit too low, 30. Oh, that's pretty. And all we're going to do is just sketch roughly what we see. So this isn't an accurate diagram, this is just a sketch. It's coming from the bottom, it's maxing before the y. Ooh, that looks terrible. Let's pretend I didn't make it that badly. Okay, so when it says sketch, it's just a quick sketch of what you see. It's not an accurately drawn graph. Oh, I'll show you that later. This calculator does things you don't even know yet.
Like games on it.
Yes, you can.
Yeah, I always see that like that like trivia thing that they're
That was a
do.
black.
I know all the answers to the questions next we're gonna like give me next. I remember that slope game from like
Okay, so because we don't have exact values, we're going to estimate. So I'm just going to make a note. These will all be estimated values. I'm going to show you tomorrow how to find them exactly on your calculator, but we just want to practice vocabulary today. So let's estimate, what do you think the vertex is? So you can either look at what you drew or you can look at the calculator itself. So what do you think the y-coordinates roughly? A y-coordinate first. So where's the turning point of the graph? The silence scares me a little bit. 25 would be way over here. We can't even see 25. Okay, so what's the x-coordinate of the turning point? 5 would be over here. -5 would be right on the x-axis. 2 would be right here. -2 would be about here. Are we better with -2? And about how high up is it? Well, you need to know what the top of the axis is, and we put in 30. So how far up do you think that is? 25? So we're going to estimate 225. Are we comfortable with that? But you don't know how to do that yet. Axis of symmetry. X equals -2. Again, I always do the direction because it matters for the max min. Direction, up or down? Max or min?
max. No, it's max. Down.
Y equals? Oh, can't be 25 because we know it has to be slightly lower. 20 is a good estimate.
Oh, it's
Domains, the freebie point. XER. You'll get a sad face. Oh, the thing, thank you. The range. It's always got to be Y. Now, if it's pointing down, it's going to be less than or equal to, and the value comes from 25 from the vertex. The y-intercept, this is actually where this should have been 25. It should be 20 down here, my fault, because it's a little bit less. X-intercepts. 2 and -5.
So 2 and what?
We said -5.